Hello everybody, welcome to Chapter 7.2, the Quadratic Formula. Solving quadratic equations by using the quadratic formula. A quadratic equation must be of the form ax squared plus or minus bx plus or minus c equals 0 in order to use the quadratic formula. This formula is given by x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c are real numbers. Solving a quadratic equation by the quadratic formula. Procedure. First, write the equation in standard form. So it must be in this form: ax squared plus or minus bx plus or minus c is equal to 0. Write down the values for a, b, and c. Substitute these values into the quadratic formula and simplify. The answers may be left in radical form. Example number 1. What are the solutions to the quadratic equation x squared plus 5x plus 6 is equal to 0? So we have x squared plus 5x plus 6 is equal to 0. So we're going to write our equation, and what I'm going to do is put the general quadratic formula underneath to show where a is. This is a, b, and c. And so we list it where a, if you don't see any number before this, you assume that is equal to 1. And we see b is equal to 5 and c is equal to 6. We then take a, b, and c and plug it into the quadratic formula. So we get, after we plug b, which is 5, and 5 for the b's, and then here for a, 1 for the a, and c, 6, all over, not just the square root part, but the entire top part is over 2a, and in this case, a is equal to 1. And then we just proceed to solve it. So we have 5 squared is 25, minus 4 times 6, well, times 1 is equal to 24, and then that's all 2 times 1 is just 2. So here we have, and this tells us that there are two answers, because we know the square root of 1 is 1, so it's going to be, the two answers are going to be negative 5 plus 1 over 2, and then negative 5 minus 1 over 2. Well, negative 5 plus 1 over 2 is negative 4 over 2. And that gives us negative 4 over 2 gives us negative 2. And then negative 5 minus 1 over 2. Well, negative 5 minus 1 is negative 6. And then divide negative 6 by 2, and you get negative 3. All right, for example number 2, let's look at example number 2, and it asks us what are the solutions of this particular quadratic. So we're going to actually use the quadratic equation for this because we have a big number here, so maybe it would be best to use the quadratic equation. We could perhaps use the other methods that we've learned to solve for x, but the thing about the quadratic equation is that it works for all equations. So we don't have to worry about the AC method, or we have to worry about some of the other methods that we've learned. Here we're going to actually just use the quadratic equation. So as before, we have it in standard form, so all we have to do is define a, b, and c. So there we have a is equal to 1, b is equal to negative 2, c is equal to negative 48. And as before, we just plug it into our quadratic equation. Where we see the b's, we put the negative 2. Where we see the a's, we put the 1. And the c, we put the negative 48. And solve as usual in order to get our two answers. And it turns out that the square root of 196 is a perfect square. So we end up with 2 plus or minus 14 over 2. And then we have our two answers. answers. 14 plus 2 over 2 is equal to 16 over 2, and that gives us 8. And then for the minus one, we have 2 minus 14 over 2, and that gives us negative 12 over 2, and this gives us negative 6. So our solution set is 8 and negative 6. For example number 3, but this time we have our A is not 1 but 2. So again we designate which our A, our B turns out to be negative 1, and our C is negative 5 as displayed here. And again, as before, we plug it into our quadratic equation. Where we see B, we'll put negative 1. Where we see A, we will put 2. And where we see C, we'll put negative 5. And then solve as usual. So here we get 1 plus or minus the square root of 41. So therefore, the solution set is 1 plus the square root of 41 over 4 and 1 minus the square root of 41 over 4. So you see here, sometimes you have fractional answers. So remember that fractions do happen. Here we have example 4. And we see the 0 is on this side of the equation. But it doesn't matter which side of the equation it's on, it's still in standard form. So whether we have 0 on the right side or it's equal to 0 on the left side, that doesn't matter because we can still designate A and B as usual. So we have our quadratic formula, and here it turns out that A is equal to 2, B is equal to 4, and here C is equal to negative 1. So as before, we just plug it in to our quadratic formula, and then we solve, use the radical, and then we do, after we finish the radical part, we add and subtract accordingly. Reduce, here we're going to reduce because 24 is 4 times 6, so that means we can pull out a 2 and get the square root of 6. Remember, it's important, if you can, simplify the radical. And here we have there, it turns out that 2 goes into all of these. So that means that we can get rid of the 2 goes into 2. 2 goes into 4 2 times. 2 goes into 4 2 times. So we simplify it to this, since, as mentioned, these are all divisible by 2 and therefore can be reduced. We have our final solution set is negative 2 plus the square root of 6 over 2, and then of course negative 2 minus the square root of 6 over 2.